The regulation of body weight, you might think, is going to require us to organize information. So if this is body weight, we're going to want to organize information so that we have paired negative feedback loops. And I'm going to tell you about what happens when we have weight gain. Weight gain sets off an increase in fat manufacture of hormone, which less eaten more moving brings down our body weight. It's a little more complicated than that, of course. And the reason we know that this is true is that we have found mutants that block this system of maintaining body weight, of restoring body weight when weight gain begins. And of course, when you have mutants in a system, that system fails to work. And so obesity is a phenotype that we have been able to use to discover how this system works. On the other hand, body weight loss sets off apparently zillions of mechanisms that restore body weight. So many, so redundant, that we don't know what these systems are. So for instance, there is a hormone called ghrelin, which is produced when we lack energy in a current status form. And yet if you knock out ghrelin, you do not knock out our ability to restore body weight. System that decreases body weight after an increase in body weight is based on the size of fat. So body fat is called adipose tissue. Much more pleasant term, yeah? And adipose tissue, when it increases, makes more leptin. Leptin is a hormone, meaning it's a molecule that travels through the blood and which is a signal for a particular subset of cells that the bloodstream serves. And remember, the bloodstream serves our entire body. But only some cells have leptin receptors. These cells are primarily found in the hypothalamus. Hypothalamus is the main part of the brain that's going to sense body status and set in motion mechanisms to maintain homeostasis. So the hypothalamus has a bunch of cells with leptin receptors. Now, some of the cells in the hypothalamus are going to lead to increased eating or nutrient uptake and reduced activity. This is a broad term, activity. It means cellular activity, but it also means motivation for organismal motility activity. Another set of cells that responds to leptin do the opposite. They lead to less eating. So their activity leads to less eating. and more activity. Here's the strange thing. Leptin binds to both of these cells. But leptin inhibits one of these cells. Which one? Leptin binds to these cells in an inhibitory fashion. Leptin binds to these cells in a activating fashion. If you reduce eating, increase activity, you're going to lower your amount of adipose tissue. If you increase eating and lower activity, you're going to increase your adipose tissue. So by slowing down the cells, these are neurons in the brain that lead to increased eating, lowered activity, by slowing those down, you are decreasing the rate of fat increase. So you're decreasing fat. By speeding these cells up, these cells that lead to decreased eating and increased activity, then you're decreasing the rate at which adipose tissue grows. You reduce the amount of adipose tissue. So leptin in this case is reducing the amount of adipose tissue. Leptin in this case too, though, is reducing the amount of adipose tissue. You see, in both cases, there is one of these negative regulation symbols.